In this problem we're asked to determine what the velocity direction is a short time after the picture being shown here. So VA is the initial velocity, and the options we have for the velocity a short time later are these 5 black arrows here. And we're told that the forces acting on the center of gravity of the aircraft are the weight, the thrust, and the aerodynamic force. So that's the forces and the velocity at time t, which I'll just denote up here in the upper left corner. And we're asked to find the velocity a short time later. Okay, so now how are we going to do that? Well, one of the things we know is we know how the velocity is changing in terms of its rate of change with time, and that's just the acceleration. And we know if we had that acceleration that we could do a Taylor series expansion. So the velocity at time t plus some small delta t is approximately the current velocity plus dv dt, which is the acceleration, times delta t. Right, so for small delta t, this will be a good approximation to the velocity a short time later there. So now the acceleration, we can use Newton to relate the acceleration to the sum of the forces divided by the mass. Okay, so the next step then is to construct what the direction is for the sum of the forces, which will give us the direction of the acceleration, and then we can use that to determine what the likely velocity direction is a little time later. Okay, so now the first force I'll put in here will be the weight. So I took the weight from over here, moved it here. Okay, and now the thrust, the same thing, adding it to the weight, and I'm going to add the aerodynamic force to that. And so those three summed together provide the entire resultant force, which is the orange vector I've got shown here. Okay, so now the acceleration then is in that direction, just scaled by 1 over the mass. And then the change in the velocity is that acceleration times some small delta t. So I can tack onto my velocity vector the sum of the forces, the direction, and I'll know that the acceleration, the change in the velocity, is somewhere along that direction here. So I'm going to extend that with a dotted line. I don't know where it is, but it's somewhere there. So if you do that, then obviously the only vector that comes close to that is the velocity vector number 1. So that says that the likely answer here is velocity vector 1 is the direction the velocity will be a short time after the instant shown.